anyway. I tried to set it up to be as user-friendly as possible. The visuals you don't really need. I have this folder for visuals. That's to give all the you see all this nasty stuff in here in the visuals folder. That's really just for the labels and stuff like that. All right. So you don't have to worry about that folder. It's just to kind of like highlight some of the important attributes of these graphs. All right. So, and in fact, if you want to turn this off, like maybe they're distracting, just tap on that folder icon and all that extra fluff will go away. All right. So what we do is we input our A, B, C, and D values based off of the equation that we're given. Here it's a simple y equals the cosine of x. The general form is y equals A cosine bx plus c plus d, which means the A value, B value, C value, and D value can be easily obtained here. The A is the coefficient of the whole thing, which is a 1. The B is the coefficient of the x, also a 1. C and D, I don't see a C and D, so they must be 0. All right, and so that actually is the default setting, 1, 1, 0, 0 for the cosine wave. Okay, it was the cosine setting, the default setting until I accidentally hit the slider. Okay. So then I would scroll down. I got my equation there. My domain should be consistent. Remember, the low bound is A, the upper bound is B. All right, that again is the default setting. So I'm good to go here. I have it set up so that the 4 boxes is correspond, so 4 boxes correspond with pi, which is how every graph in the packet is set up. So now it's just a matter of labeling things up and getting it to look the way I want. So here's pi. Again, that should be a tick mark. 4 more would be 2 pi. Negative pi. Negative 2 pi. All right. So at negative 2 pi, I'm at a y value of 1. I just got to decide where I want to put the 1. They said 4 boxes. I don't really disagree with that. So I'll call this 1 and I'll call this negative 1. All right. So at negative 2 pi, I have a 1. Halfway between negative 2 pi and negative pi, I'm at the x-axis, so I'll just plot a point there. At negative pi, I'm at negative 1. If you're not sure, just tap on the point. It'll tell you the coordinates. Negative pi over 2, that's halfway between 0 and negative pi. A 1. A pi over 2. A negative 1. Halfway between pi and 2 pi, I'm back to the x-axis. And then up to the maximum point. I just plot the extremes and the midline values and draw a nice smooth curve through all those points. And I have my graph. All right, but then, you see the next one, I'm kind of jazzing things up a little bit. All right, so instead of having an A and B value of 1 and 1, I have an A value of 2. So the general form here, A sine bx plus c plus d. The A value is equal to a 2. The B value, also a 2. C value and D value, 0 and 0. So I'd go to my sine wave grapher. All right. I just got to take note of my new domain, which is A to B. Got to label my graph. I'm only going from negative pi to 2 pi. All right. So then I'll toggle my A, B, and C values to the appropriate location. My domain should be going from negative pi to 2 pi. So this is what my graph ought to look like. I see my amplitude and period is actually labeled out for me. And this is really nice because if you think to the practice test, any graph where you're given you're given the graph and you have to come up with the equation, you have a way of referencing what component is the amplitude, what's the period and the frequency and all that stuff. So it's pretty nice in that regard. All right. So I just want to plot these values. You know, you can just start like tapping on things and see what comes up, or you can just eyeball it and say, okay, I'm on the midline at negative pi. I'm at the maximum point, which is a value of 2. Now I can eyeball where that's going to be. I'm just going to put 2 at the top and a negative 2 at the bottom. Just to make it look a little nicer, but it really doesn't matter where you put it, right? Because the midline's on the x-axis, right? So I know between 0 and negative pi, I'm back to the midline. So it looks like every 2 points, I'm on the midline. So I can get all those in there. And it looks like in between, I'm alternating between maximum and minimum. So between negative pi and this one here, which is negative pi over 2. All right. In between those two, directly in between, I'm at the maximum. Directly in between negative pi over 2 and 0, I'm at the minimum. So I'm looking at that graph. All right. Now, periodic functions repeat over and over again throughout their domain. So this same pattern has to propagate throughout the entire domain. So that's another cycle. And then we have one more cycle. All right. So working backwards isn't really that challenging because as long as you're able to figure out what the period is, you know, how far you have to go out in order to get to the appropriate, how far you have to go out in order to get the one full cycle, which would give you the appropriate length. Then you're in pretty good shape because the amplitude is usually pretty easy to pick out. In a lot of cases, it's a matter of just sliding some sliders around until what you have fits, or what you have as an equation fits the diagram that's given to you. Let me just do one more, something that's a little on the juicier side. Oh, overshot the mark. So like something like number 9 on page 44. So cosine graph. So the A value for the B value, remember it's A cosine bx plus c plus d. All right, so the B value is the coefficient of x. X over 2 is really the same as saying 1/2 x. So the B value is 1/2. C is equal to pi. That's fun. And D is equal to -6. All right. So slide this one over to a 4. You just type it in also because you see how I struggle with it. 1/2, so 0.5. Now try as you might, you're not going to get this to become a pi. So you just type it in. And then the D value, we make that a -6. And you can see the whole graph is sliding down out of the frame here. But if I clean up by shifting things over, I get a better idea what's going on. Now my domain is going from an A value of 0 pi to a B value of 4 pi. 0 pi is the same as 0, so I can just put that in. But I'll leave the pi there as a placeholder. And then the B value again is 4 pi. Oh, I guess there's something wrong with my code. That's weird. Well, the whole visual part of it kind of fell apart there, but this is what the graph ought to look like. So this is correct. It just doesn't have all the bells and whistles along with it. I have to check and see why that happened. But this needs to go out to 4 pi, and pi is 6 units this time. All right, so 1, 2, 3, 4, 5, 6. So 2 pi, 3 pi, 4 pi. All right. The midline is always whatever the D value is. All right. So I don't have 6 units to work with here. I got to go down as far as -10. So if I want to go down as far as -10, I think I probably got to go by 2. So -2, -4, -6, -8, -10. On the y-axis, I would plot the -10. That's easy enough. At 2 pi, I'm plotting -2, also easy enough. And at the end point here, if it'll let me, at that end point, which is at 4 pi, for whatever reason I can't get it to lock on, it's still at -10. You can tell that visually. All right. But at -6, I have another point here, and that other point looks to be at pi. All right. At -6 on this side, hard to see by the decimal, but that looks like it's directly between 2 pi and 4 pi. So that would put it at 3 pi. So -6 should be at pi and 3 pi. So now, even though it's going to look a little wider than it does in Desmos, it's still going to be a correct graph, just the scaling is a little bit different. But that's what your trig function would look like. All right. Now the word problems, there's really not much to do there, because if you looked at the one on the practice test, it's really just a matter of evaluating the function. So all it's really giving you is a contextual situation, and this is all I'm going to do on the test. I'm just going to give you a contextual situation, but then I'll give you the equation. It's not like one of those other word problems with the logs and exponentials where you have to build the equation yourself. We're not going to do that with trig, because that's too advanced at this point. We don't have enough trig knowledge yet, but we will in the 3rd unit. So be on the lookout for that. That'll be a fun application in the 3rd unit. But for now, here's a little backstory. Here's an equation. Either graph it or plug in some values and see how it goes. All right. It's pretty straightforward, because if you've taken a look at the word problem on the practice test, you see it's really not that bad. Even that's why I hesitate to do any of these examples, because these are actually way more complicated than anything I would ask you to do on the test. All right. So a good example of what you could expect to see on the test is exactly what you see on the practice test. Right. And just watch the video on that, because I don't want to keep you all night, but it's also very straightforward, where you just put your equation into your calculator, plug in a couple of numbers, and answer the question. All right. So that should be the easy part of it. So yeah, Anyway, so let me stop the recording.